In this section, we will learn about Python's math module. First, we will get an introductory look and overview of Python's math module. Next, we will learn about the different constants that we have available to us in the math module. After that, we will learn about the different functions that the math module gives us access to. There will be a video on number theoretic and representation functions, a video on power and logarithmic functions, a video on trigonometric functions, a video on angular conversion functions, and a video on hyperbolic functions. After that will come a coding exercise that will challenge you to apply the concepts you learned in this section of the course hands-on. Finally, we will look at a recap of what we learned in this section of the course. In the next lecture, we will look at an overview of Python's math module. In this lecture, we will take a look at Python's math module. The math module gives us access to some commonly used mathematical functions. This is actually really useful. For example, if you had to raise a number to a certain exponent, or take the log of a certain number, you would have had to create your own function with your own code logic. Not only could this become complicated, but there is also room for human error. If you type something wrong, then any time that function is called, your code may output the wrong result. The great thing about the math library is that these functions are provided to us, and we know that they work, so there is no reason to reinvent the wheel by implementing them from scratch. I've broken down the study of Python's math library into the following segments that we will look at in the videos in this section of the course: constants, number theoretic and representation functions, power and logarithmic functions, trigonometric functions, angular conversion functions, and hyperbolic functions. In the next lecture, we will learn about the different constants that the math module supports. In this lecture, we will learn about the various constants that the Python math module contains. The first step to working with Python's math module is to import it at the top of our program by typing import math. This will import all of the constants and functions from that module into our program so that we can use them in our code. One of the most important constants in all of mathematics is pi. To access this constant, we can reference math.pi. Let's print out the value of math.pi to the console. When we run the code, you will notice that the value 3.1415, etc. was printed to the console. Anyone familiar with this constant will be able to identify that this is indeed the correct value. Another important constant is e. E is Euler's number and is the base of the natural logarithm. To see the value of this constant, we can use Python's print function and print the value of math.e to the console. When we run the code, you will notice that the value 2.71828, etc. was printed to the console. The tau constant is equal to 2 times pi. Let's print out math.tau and run the code. As you can see, the value is 6.2831, etc., which is approximately 2 times the value of pi. The next two constants we are going to look at are a little bit different than the others. These constants are inf and non. Instead of having numerical values, they have sort of abstract values just with their letters. The math.inf constant stands for infinity. We can print out the value of math.inf to the console. When we run the code, you will notice that inf was printed to the console. The math library's non-constant stands for not a number, and basically identifies just that, any numeric value that is undefined. For example, we can print out math.non to the console. When we run the code, you will notice that non was printed to the console. In the next lecture, we will learn about the number theoretic and representation functions that Python's math module gives us access to. In this lecture, we will learn about the number theoretic and representation functions that the Python math module gives us access to. Up at the top of the program, we will import the math module by typing import math. The ceil function allows us to round up a number regardless of the decimal value. For example, let's print out math.ceil and pass in the float 2.3. Normally, 2.3 should be rounded down to 2, since the decimal value 3 is closer to 2 than 3. However, with the ceil function, we are telling Python to round the float up to the nearest value. In this case, when we run the code, you will notice that 2.3 was rounded up to the integer value 3. The copy sign function takes in two parameters. The first is the value that it will keep. The second is the sign. For example, we can print out math.copySign and pass in 2.5 as the first argument and -1 as the second argument. When we run the code, you will notice that -2.5 was printed to the console. The fabs function allows us to get the absolute value for the number we pass in. For example, we will print out math.fabs and pass in negative 1.0. When we run the code, you will notice that 1.0 was printed to the PyCharm console. The factorial function will give us the factorial of the number that we pass in. For example, we can print out math.factorial and pass in 3 to get the factorial of 3. Remember that a factorial means we would multiply the 3 by 2 by 1, which results in a value of 6. When we run the code, you will notice that 6 was printed, which is the factorial of 3. The opposite of the CL function we learned about earlier is the floor function, which will round down a float to an integer regardless of the decimal value. Usually 3.9 would be rounded up to 4, but since we are using the floor function, it will be rounded down to 3. When we run the code, you will notice that 3 was printed to the PyCharm console. Another useful function that the math module gives us access to is the fsum function. This function allows us to get the sum of a sequence of numbers inside of a collection. For example, let's use the fsum function and print out the sum of a list with the values 1, 2, 3, and 4. When we run the code, you will notice that 10 was printed to the console. GCD stands for greatest common denominator, the greatest number that both numbers can be divided by. Python's math module provides us the GCD function that takes in two parameters, the two numbers we want the greatest common denominator of. For example, let's use the GCD function and pass in 3 as the first argument and 6 as the second argument. When we run the code, you will notice that 3 was printed to the PyCharm console. Another common mathematical operation is to get the square root of a number. The math module gives us the sqrt function to obtain a number's square root. For example, let's print out the square root of 25. When we run the code, you will notice that 5 was printed to the PyCharm console. In the next lecture, we will learn about the power and logarithmic functions that the Python math module gives us access to. In this lecture, we will learn about the power and logarithmic functions that the Python math module gives us access to. At the top of the program, we need to import the math module. The exp function will return e raised to the power of the number we specify. For example, let's print out math.exp with 2 passed in. When we run the code, notice that 7.389 was printed to the console. The expm1 function will return e raised to the power we specify minus 1. Let's print out the result of math.expm1 with 2 passed in. When we run the code, notice that 6.389 was printed to the console. Recall that our last result was 7.389, so this is indeed that number minus 1. The log function will give us the logarithm of the number we pass in. For example, let's print out math.log and pass in 100. When we run the code, you will notice that 4.605 was logged to the console. The log1p function will give us the natural logarithm of 1 plus x. For example, let's print out math.log1p and pass in 100. When we run the code, you will notice that 4.615 was printed to the console. To get the base 2 logarithm of a number, we can use the log2 function. For example, let's print out the result of math.log2 and pass in 100. When we run the code, you will notice that 6.643 was logged to the console. The log10 function will allow us to get the base 10 logarithm of the number we specify. For example, we can print out math.log10 and pass in 100. When we run the code, you will notice that 2 was printed to the console. The math module's pow function allows us to raise a specified number to a specified power. For example, let's print out the result of math.pow and pass in 2 as the first argument and 3 as the second argument. This will raise 2 to the third power. When we run the code, notice that 8 was printed to the console. To get the square root of a number, we can use the square root function. For example, let's print out math.sqrt and pass in 25. When we run the code, you will notice that 5 was logged to the console. In the next lecture, we will learn about the trigonometric functions that the Python math module gives us access to.